Okay, so dividing with polynomials. I'm going to approach this as reducing fractions. In the next chapter, we're going to get a bunch of rules for exponents, and we're going to do more complicated versions of these. And so right now, I'm just going to treat it as canceling problems, because that is one way to look at it. And I think it's actually pretty intuitive that way, and my hope is that it will help out when we get the rules that people have a little bit more trouble applying. So, reducing a fraction. If I have something here like 12 over 20x, what I want to do is I can cancel when I have basically the same thing in the numerator and the denominator. And the reason for that is that would be a version of 1. So say I have 7 over 7. 7 over 7, those would be the same thing. They would reduce to it equals 1. So it makes sense if I have 7 times 2 over 7 times 19, whatever that is, I can cancel out that 7 over 7 because it's a 1, and that leaves me a reduced fraction. So that idea is how I'm going to approach these problems. And I could factor these down to primes, which would be totally legitimate. I'm going to try to make it a little easier where I can. And if you can spot that 4 times 3, 4 is the biggest thing that goes into 12 and 20, that's kind of nice, because then you can just think of that top as 4 times 3. The denominator, we can make that 4 times 5 with the x. And then see how if I go 4 over 4, 4 over 4 is 1. And so what's left right here, that's the reduced form of that fraction. And so that's a version of dividing is essentially just reducing. Let me do the same thing here. So 14s and 21s. So I feel some 7s are going to be able to cancel. So I'll call that 14 a 2 times 7. C, and then I have a d squared. I'm going to, for this homework only, I'm going to write out those d's. Again, I'm going to show you another way once we get to the next chapter. But this is just sort of a more intuitive approach to reducing the fractions. So 21, I'm going to call that one 3 times 7, and then c, d. And so everywhere where I have the same thing in the numerator and the denominator, it's a 1. So 7 over 7, that's 1. C over c, that's 1. And then d over d is 1. So if I look at what's left, that's my reduced fraction. So 2d over 3 is my reduced form. And then up next here we got 30x squared y cubed. So let me get that written out. Oh, and then 36 is also coming up. So with that 30 and 36, it's going to be a 6, right? That's going to be the biggest thing that goes into both. So I'm going to write that 30 as 5 times 6. And I got a pair of x's, so let me write x and x, and I got y cubed, y. And again, we'll come up with a better version in the next chapter. 6 times 6, x, and y times y. And when I say a better version, I actually am doing the exact same math. You just get, hopefully, where you don't show this step. And maybe I'll show that on this problem as well. So here we'd have the 6's would cancel. Have some x's there. X over x would cancel. Y over y would cancel. And I got another y over y canceling. So that would leave me 5. There's an x left and a y. And then a 6, and that's it. Let me rewrite this bigger right here and show you kind of where we're going to head with this, or at least a way of thinking about it. So if the 30 over 36, I would still be doing the same thing. I'd be going 6 goes into 35 times and 6 goes into 36 times. When I see x squared over x, I think I have 2 up and 1 down. That's going to leave me 1 in the numerator because it's doing this math. So I don't write this out, but this is kind of what I'm envisioning as to why that canceling works. Y cubed over y squared, I'm thinking I got 3 up, I got 2 down, so cancel. That would leave me that 1. So this isn't something I necessarily think you should show, but it's just hopefully a visual to help you see where things are disappearing or how they're disappearing. Okay, so for here, we're going to divide polynomials by monomial. And so I have this kind of cheesy way of writing it, but I'm just showing that if we have some terms up in the numerator and a monomial in the denominator, what that means is this a belongs to every single one of these terms. So I can split something that looks like this into something that looks like that. And then we're just doing 3 little reductions in this case, or 2, or however many we have. but it becomes 3 problems just like the little ones we're doing instead of kind of this big chunky one. So here this is 24x plus 40 over 8. So let me write this as 24x over 8 plus 40 over 8. And I don't even have to rewrite it. Once I realize that it means this, then that's cool. I can just kind of do the 8 into both. But I'm going to show this step just to kind of help you see, hopefully, how the canceling is happening. So 24 over 8 would be 3x, and then 40 over 8, that would be 5. And so there's our reduced form of this fraction. Again, you don't have to write it out. Once you know it, you can just go, okay, 8 into 24 is 3. But what I don't want you to think is that leaves 40. You got to know that the 8 belongs to the 24 and the 40. That's the important thing. This one right here, this is written with that division symbol. So really, it's the exact same thing as 24 minus 20x all over 4x. And then I'm going to write it over 4x just to kind of get it in this form. So 24 over 4, that would be 6. Here I got 2 x's up, 1 down, so that's going to leave me x. 20 divided by 4, that will be 5, and then x over x would cancel. So 6x minus 5. Okay, and then these last couple, let me rewrite them. So 4x over 20 plus 4x over 12 plus 20 over 12. So reducing here, I would have x, 4 goes into 12 3 times. So think of that as like a 4 times 1 over 4 times 3. So we're canceling and we're getting the same thing as 1/3 x, which would be x over 3. Here with this 20, this would be like a 5 times 4 over 3 times 4. So we're reducing the 4s. So that would be plus 5/3. And then the computer, I'm not sure if they'll want that form. Sometimes they'll have it set up with a box where they have it set up as a fraction when this comes out the same. So I'm not sure on the formatting. I feel like it's this one, but it could be that. Or it could be able to take either one. Number 5, this one I bet they do want typed this way. So let me, I'm going to rewrite this whole thing with a little bit bigger and then with that 6x showing in all the denominators. Okay, so here's this negative 6x, but now just kind of broken out 3 times. So we can see right there we got 2 negative signs, and a negative divided by a negative is a positive, so that will be a positive 5. I got 2 x's up, x squared, 1 down, so that's going to leave me x. Again, just think of that canceling, right, just like that. So it's leaving us 1 up in the numerator. 18 divided by 6 would be 3, plus a minus is minus, so that's minus 3. The x's cancel. Plus a minus again, so that's another negative. And then here, this x ended up in the denominator. And that's okay, that can happen. It just needs to stay there.